Okay, so basically today is the last session of chapter 2, and today I'm basically going to discuss two important concepts. One is stack and heap memory. We need to understand what is stack memory and what is heap memory when we created a variable, where the variable is going to be created, whether it is going to be created in the stack memory or whether it is going to be created in the heap memory. Good morning. Yeah, so that we need to understand, and we also need to understand when the object is going to be destroyed. That is, the memory allocation is when the memory allocation is destroyed from the stack memory, and when the memory is released from the heap memory. That we will also discuss, and then we will discuss one of the important concept, that is boxing and unboxing. Right? Initially, when I prepared this syllabus, this chapter was not there, right? But in my previous batch they told me to they told me to include this concept also. So in my previous batch I have included this concept, so I also include into this batch, right? So in your batch, if anybody have any topic which is not covered in the syllabus, then they can also let me know so that I can include that topic as well, right? So basically today's agenda is we are going to discuss what are exactly stack and heap memory, and how we can utilize the stack and heap memory, and then we'll discuss boxing and unboxing concept, right? So let's start today's session. My screen is visible to all of you, right?
Yes, sir.
Visible, right? So basically, as you can see, what we are going to discuss now, we are going to discuss what happens internally when we declare a variable of value type as well as reference type. We have discussed. So the type which is derived from the struct is called value type, and if the type is a class, then it's going to be a reference type. And we have already discussed that integer, float, boolean, byte, all these are value types because they are internally. If you go to the definition, then you will see that the type is struct. And if you go to the object data type, string data type, or any user defined data type that we created, like employee, like student, they are going to be reference type. And if you check their definition, they are going to be of type class. Let us understand this. Suppose I am declaring one integer variable, right? Integer x equals to 20. I'm declaring one string variable, string str equals to some high value, right? So now if you go to the definition of int data type, then you will see that the type is struct. Let's see. See, the type is struct. Whenever you see the type is struct, it means it's a value data type, right? It means it's a value data type. What exactly value data type means? Value data type is going to hold a single value, a scalar value at any particular given of time, right? You cannot store multiple values inside a value data type. For example, if I am going to store x equals to 20, means 20 is going to be stored. Right? If I'm writing like this, x equals to 30, then you will see that this 20 and 30 both are not going to be stored. Right? So 20 will be removed and 30 will be stored in that place. Now, if you go to the reference data type, then you will see that it's a class. So whenever you see the type is a class, means it's a reference data type. And in the case of a reference data type, they are not going to hold the value directly. In this str variable, this high value is not going to store. What value is going to store? This high value is going to be stored somewhere else in the memory. That memory address is going to be stored inside this str variable. That we will see in practical. So the thing that you need to understand, we have two types of a data type. We have value data type and we have a reference data type. If the type is struct, it's a value data type. If the type is class, then it's a reference data. So if you take object, so if you go to the object definition, then you will see that it's a class. It's a class means it's a reference data type, right? Now, if you create any class, right? Suppose I'm creating one class called example class. So means it's a class. Class means here example. Example, its type is class means it's a reference database. That is what you need to understand. So we will discuss what internally happens when we declare a variable of value type as well as reference type. So once we discuss this, then we'll move forward and we'll discuss two important concepts, that is stack and heap memory and the differences between them. Let us understand what happens internally when we declare a variable in .NET application. So when we declare a variable in .NET application, it allocates some memory in the RAM, right? As we already discussed, if we are creating variable for what? We are creating variable to store some data, right? If we are going to store some data, then for storing those data, we need some memory in the computer, yes or no? And that memory is going to be allocated inside the hard disk or inside the RAM, inside the RAM only. Yes, in RAM we have a different kind of memories like heap memory, like stack memory, that we will discuss. But whenever we declare a variable, it means a memory will allocated inside the RAM, right? And how much a byte of memory it is going to allocate it, that basically decided by the data type of the variable, right? If the data type is int, it is going to allocate 4 byte of memory. If the data type is character, it is going to allocate 1 byte of memory, right? If the data type is byte, it is going to allocate 1 byte of memory. If the data type is float, then it is going to allocate 8 byte of memory, right? So basically, what is the size? That you can go to the definition of the data type and you will come to know what is the size. For example, if you are not sure what is the size of the integer data type, so you can go to the definition and it is saying 32 bit. 32 bit means it is equivalent to 4 byte. Now, suppose if you are declaring one character ch, and you are not sure what is the size, so you can go to the definition, right? And you will see that it is a UTF 16. 16 means it's a 2 byte of memory, right? Even though you can also get the size of the data type by using something called size of function. Size of, suppose you want to know the size of memory, so you can write like this. Console dot read size of integer. So size of a float, I'm writing like this, size of float, right? I'm writing slide or size of a double. I'm writing size of a decimal. Any numeric data type, you can write like this, and you can get the size of the data, right? So now if you run the application, then you will see that it will represent the size of the respective data. Let's see the output. See, 4, 4, 8, 16. That means for integer, the size is 4 byte. For float, the size is 4 byte. For double, the size is 8 byte. For decimal, the size is 16 byte. Right? So this is the size of the data type. If you are not sure, you can use this size of operator to know the size of the data type. Even if you go to the definition of the respective data type, then you will also see it is clearly mentioned represent a single precision floating point number. Here it is not mentioning, right? But if you want to know, you can use the size of operator. But in this case, if you go to the definition, right? So if you go to the integer, then you will go to know the what is the size. Yeah. So it is representing 32. Sometimes it is mentioned in the definition. If it is not mentioned, then the other way of getting the size or to know the size, you can use the size of operator, right? See, the memory, when we declare a variable in .NET application, it allocates some memory inside the RAM. The memory that it allocates in RAM has three things: name of the variable, data type of the variable, value of the variable. Please have a look at this image, right? Suppose I am declaring integer I equals to 10. Then here, three things are there. One is type. Type is integer. One is name. Name is I. And one is value. Value is 101. So inside the computer memory, it will allocate these three things. So this type means integer. It means it will allocate some 4 bytes of memory inside the computer. I means name, name means I. It will give the identification to that memory location as I. Then value is 100. So it will store that value 100 inside that memory location. Is that clear? So from this statement, we can consume that, we can understand that it will allocate some 4 bytes of memory with the name I, where it will store 101 inside the RAM. Is that clear? Guys?
Yes. Yes.
Yes. Right. So by looking at this statement, you should understand. Yes, it is going to allocate some 4 bytes of memory. How you are identify 4 bytes? Because the size of the int data type is 4. If I'm taking float, then also the size is 4. Right. If I'm taking character, then size is going to be 2 bytes. So based on the data type, the size will be decided. And I is nothing but it's the identification. It's the identifier. It is the name of that memory location. Right. So we are saying that variable is nothing but the named memory location. So it is nothing but the name of that memory location whose size is 4 byte and where we store the value 101. Right now. Now let us understand the stack and heap memory and try to understand when the stack memory is created, how the stack memory is going to be work, and same in the case of a heap memory. Right. So please observe this diagram. So there are two types of a memory allocation for the variables that we created in .NET application, right? So whenever we create some variables, then the memory allocation for those variables either in the stack memory or in the heap memory, right? So in order to understand stack and heap memory, please have a look at the following example. Here I have one method called the sum method, and in this sum method I have written 3 statements. One statement is integer variable declaration, another statement is another integer variable declaration, and another statement is it's a sum class. Sum class means it's a reference type variable declaration, right? The first 2 statements are value type declaration, value type variables, and the third statement is a reference type variable. Is that clear?
Yes, sir.
Okay. Now let's see what happened when we execute this first statement. When this statement, right, integer x equals to 101 is executed, then what will happen? See, when integer x equals to 101 executed, so it will allocate 4 byte of memory inside the stack. So whenever the point that you need to remember, whenever you create a value type variable, right, that memory allocation is going to be done inside the stack, right? So x is a value type or reference type?
Value type.
Value type, because int is a value data type. So value type means its memory allocation is going to be done inside the stack only. See here, this block, you can assume that it's 4 bytes of memory, its name is x, and here it is storing 101. Is that clear?
Yes, sir.
Right. And the second statement, when the second statement is executed, you already know the working principle of a stack. Stack means LIFO principle, last in, first out, right? That means if you want to put, suppose you have a collection of a plate, and if you want to put another plate, then you are going to put that plate on top of the plate or not, right? That means in the same way, you have created one memory, and if you want to create another memory inside the stack, then it is going to be created on top of the first memory, right? So in this case, integer x equals to 100, that is already created. And if you want to create integer y equals to 102, that means it is going to be created on top of the variable x. Because stack work on the principle of a LIFO. And we know LIFO means last in, first out. That what it means? It means all the functionality. If you want to insert the element and if you want to delete the element, everything is going to be performed on one end. That is on top of the stack, right? So this is top of the stack. If you want to insert, here only you need to insert, and if you want to remove, then here only you want to remove. There are no two-way activities. Only one end where you can insert the element, where you can delete the element. That is the principle of stack, right? The same principle also applicable to here. You already created one memory. When the first statement is created, this X memory allocation is done. And when you want to create the another memory, that is Y, right? Then that memory allocation will be done on top of the X memory allocation. Why? Because it will work on the principle of stack. Is that clear?
Yes, sir.
Yes. Right? So in this case, this Y memory allocation is going to be done on top of the X memory allocation. Here, it will again create 4 bytes of memory, and there it will store the value 102. Right? Is that clear? Okay. Now what happened when the third statement is going to be executed, right? This third statement is not a value type. It's a reference type. Because it's a class. Some class means it's a class. And whenever a reference type is executed, the object creation is going to happen inside the stack memory. Sorry, inside the heap memory. See, there are the two statements. Some class CLS1, this is the variable, and the new sum class, this is the object. So when this new sum class executed, the object is going to be created inside the stack memory. Sorry, inside the heap memory, right? And inside the stack memory, that basically depends whether you have any reference variable or not. If you have any reference variable assignment there, then that reference variable is going to be created inside the stack, and it will point to the object that is created inside the heap. So here two things are happening. One is object creation. Object creation means when the new, see whenever you are seeing this new keyword in your application, that new keyword is basically used to allocate the memory inside the heap. That is called a dynamic memory, right? These are your running memory. To run your application, this memory is required. And to store some data for some more time, you need heap memory, right? So in this case, new sum class is nothing but your dynamic memory you can consider. And whenever you use the new keyword to allocate some memory, then that memory allocation will be done inside the heap memory. So new sum class, that memory allocation is going to be happen inside this heap memory, right? Then what is this CLS? CLS, it's a reference, right? And as we already discussed, so this CLS reference means it is going to point the base address of this CLS1 object, right? So what is the address of this memory? That will be stored inside this CLS1 reference, right? And then you might be asking one question, sir, what is the size of this CLS1? It's 4 bytes, because the address is always going to be positive integer. As positive integer, it will be the same size as an integer data type. Is that clear?
Yes, sir.
Okay. See why I'm saying this is the object creation statement, because without this sum class CLS1, we can create the object and we can access the data memory. Let's see this one. Okay. Suppose, right? Suppose I'm creating one variable here, void some method, right? Void some method, and here I'm doing some simple console.writeLine statement, method executed. Right now this is a non-static method or static method? This sum method is a static method or non-static method?
Non-static.
Sorry,
Non-static.
non-static, right? So if you want to invoke or if you want to call any non-static member of a class, then can I call that member directly, or do I need to require to create an instance of the class?
You need to create instance of the class.
Right? So you are saying you can create like this, or you can invoke the method like this, right? So you can invoke this method like this. Yes or no? Yes or no?
Yes.
Then you are assuming that this is your object. Yes or no?
Yes.
But in reality, this demo is not your object. right? Who is your object? The object is this one. This object reference we are storing in this demo variable, right? To prove this, okay, let us split this, right? Why I'm saying, okay, now if I invoke this, what I'm saying, I'm getting some error or not? I'm getting some error or not?
Yes.
You are getting error because this is not your object. This is just a variable, and this variable is not initializing, right? So you cannot call this method. So you can see here I am getting the error. Now, instead of calling this, what I am doing, I'm using this one, right? Am I getting any error?
No.
No. That means if you want to create a static, if you want to invoke any non-static member, then you need an instance of a class. Instance in the sense object of a class, right? So if this one is your object, then you should not get any error, right? If this one is your object, then you should not get any error when you invoke the method like this, right? But in this case, you are getting error, right? You are getting error here. But in this case, you are not getting error. No error. Why? Because this is your object. Object is this one only. And using object, you are calling this method, right? So in this case, what will happen? There is no reference variable. So you can invoke. But in this case, if you want to store the reference, you can later or further, you can use the same object to invoke other methods, right? So in this case, suppose I am having another method, some method 2, right? Then I cannot invoke the sum method using this object because I am not storing the reference. Why we are storing this reference? Why we are storing this object reference? Now we are storing this object reference to call multiple methods. So in this case, we are not getting error. Now see, as soon as I store the object reference in this variable, this error is gone. Now using this same object reference, I can call the same method 1 also, same method 2 also, right? So why we are storing the object reference? For future use. If your only suppose you want to create one object and you just want to invoke a single method, then it is not required to store the reference variable like this. You can directly invoke the method like this. This is also acceptable, right? So the point that you need to remember is this is not your object. This is just a variable. And this is your object. So whenever you see new keyword in your application, that new keyword will allocate memory for the reference type. And this is your constructor, and this constructor will initialize all the non-static members of your class, right? If you are seeing the new keyword, means it's a reference type. And this is your object, not this one. Then what is this? This is just a variable, right? This is just a variable. And we call this variable as a reference variable. Why? Because it holds the reference address of an object, right? Suppose I am creating one variable like this. So in this case, this is not a reference variable. This is a normal variable because this X not holding any reference address. What X is holding? It is holding the value directly, right? In this case, we are calling this as a reference variable. Why? Because this is not holding the
My voice is breaking, sir. Sorry.
Yeah.
Sir, your voice is breaking.
Okay. Is it fine now?
Yes, sir.
Yes, sir.
Yes.
Yeah, actually, I think you have joined later because in the starting only I have told everyone I'm in my hometown. So here I do not have any Wi-Fi connectivity, right? I'm connecting through my mobile network. So sometimes if my voice is not audible or if my screen is freeze, then please let me know. Okay. So now it's better.
Yes, sir.
Yeah.
Okay. So the point that you need to understand, this is not your object. Object is this one. Then what is this? This is just a variable like X is a variable where you store the value 10. So here demo is just a variable where you told the object address, right? So in this case, if you look at the image, so this is your object, the class 1 object. And if this object address is 101011, then that 101011 will be stored inside this CLS1 variable. Understand or not?
Yes, sir.
Okay. And this variable will have a pointer or will point to this object, right? So the heap memory is used for a dynamic memory allocation, and the stack memory is used for running memory allocation. To run your application, whatever the memory is required, that will be created inside the stack. And if you want to store some object, dynamic object, right? Dynamic memory allocation, that will be done inside the heap memory. So the point that you need to remember is, if you are creating a variable of value type, then the memory allocation will be done inside the stack memory. For this, X and Y are going to be created inside the stack memory. And if you are creating a variable of reference type, then that variable will be created inside the stack memory, but the actual object is going to be created inside the heap memory, and that reference variable will have a pointer to that actual object. Is that clear?
Yes, sir.
Okay. Now, so these three statements are executed. The reference pointer are allocated on the stack. The statement CLS doesn't allocate any memory for the instance, right? So some class CLS, it will not allocate any memory. So in this case, suppose in this case, if it allocate memory, then you should have then you should not get any error like this, right? We are getting error because it doesn't allocate in memory, right? When you use the new keyword, then only the memory allocation is stored, and that reference will be stored inside this memory. And using that reference, you can invoke. Using that reference, you can invoke. Even directly using the object, you can also invoke the method, right? So now if you run the application, you will see all are executed without any error. So this statement is also going to be executed without any error. See, method execute. So this is the point that you need to remember, right? Now the question is, so we understand what are stack memory. Stack memory is nothing but your running memory. Whenever you create any variable, right, that variable will be created inside the stack memory, right? If it's a value type, then the value it is going to store, and if it's a reference type, then it is going to store the object reference, right? In the case of a reference type, the actual object is going to be created inside the heap memory, and that reference will be created inside the stack memory, which will have a point, which will point to the actual object. Now, so what will happen when this method completes its execution, right? So what will happen when the, see, you call this method. Inside this method, these three statements are executed. And we understand that when these three statements are executed, this is what happening inside the memory, right? Now we are going to understand when the method completes its execution. Completes its execution means when the close curly braces is executed, then what will happen inside the computer memory? That we need to understand, right? When the three statements are executed, the control will exit from the method. When it passes the end control means this end curly braces, it will clear all the variables which are created on inside the stack. You can see the stack memory is clear, right? So once this method execution started, these variables are created inside the stack memory, and these variables are created in what manner? In this stack manner, right? LIFO principle. So first, then on top of the X, Y, on top of the Y, CLS1, right? And when the end statement is executed, so first it will clear this one because it's a stack principle. Whichever is the top of the topmost element, that it will delete first. Once it deletes CLS1, it will delete Y. Once it delete Y, it will delete X. That means all these three are going to be deleted when the end of this curly braces is executed. Then what happens to this CLS1 object? It will not deleted. See, once you complete the execution of this sum method, this object is not going to be deleted immediately, right? So because this is not your running memory. Running memory is stack. Once the method completes the execution, running memory is going to be deleted. This is your dynamic memory. It is not going to be deleted when you complete or when your method completes its execution, right? It will be there. Then the question is, who is going to delete it? See, here you can see Once this statement is executed, this stack memory is free. But this is not going to be deleted. Right? Then the question is, who is going to be deleted this memory? There is a concept called garbage collection. See, in our next chapter, we will discuss garbage collection in detail, right? So somewhere you will see garbage collection in .NET, right? So this memory is going to be deleted by garbage. So there are different generations of garbage collection, right? Generation 0, generation 1, generation 2. Whenever you created a memory, whenever you created a reference type, it will be created in generation 1. Then from generation 1, it will move to generation 2. From generation 2, it will move to generation 3, right? The garbage collector frequently visit to generation 0, comparing with the 1 and 2. Then we need to understand when it is going to move the object from generation 0 to generation 1 and from generation 1 to generation 2, and why it is moving and why we have 3 different generations, right? We will discuss those things in detail, right? It is not like we have gc.collect method, we will call that method to delete the unused object. That is not the scenario. We need to understand what is the architecture behind the garbage collection, right? So what are the different kind of generations? When at what generation which memory is going to be allocated? When the generation 0 is going to be deleted? How the memory is going to be deleted? We'll discuss that in detail, because that is altogether a different topic altogether, right? So this heap memory, so whatever memory allocation will be done inside the heap is going to be destroyed by garbage collector. The point that you need to remember, garbage collector will not delete your stack memory. Garbage collector is going to delete your heap memory. Stack memory is automatically deleted whenever your method completes its execution. But heap memory is not automatically deleted, right? Heap memory is automatically deleted in .NET framework, but that is going to be deleted by the component called garbage collector, right? We'll discuss that garbage collection in detail. But for now, you just remember, whenever you create a value type, then the memory allocation will be done inside the stack memory. And whenever you create a reference type, the object is going to be created inside the heap memory, and the reference variable is going to be created inside the stack memory, and that reference variable will point to the actual object, right? So if you remember, okay. Not this one. Not this one. Not this one. See, here you can see. So here you can see we are creating two customer objects, customer C1 and customer C2, right? So in customer class, we have two properties, first name and last name. You can see. So whenever you create the customer C1 object, right, the object is created inside which memory? Heap memory, right? Inside this heap memory, this first name and last name memory allocation will be done, and there you will store the actual values, right? And this is the customer object, and this is the customer base address. And you can see this is your stack memory. Inside stack memory, the reference variable C1 is going to be created. And this C1 actually what it is, internet issue. Okay. And this C1, it is actually pointing to the actual object. So it is not holding any value. Rather, it is holding the object address of this, right? This is your dynamic memory. This is your running memory. You can say this is stack memory. This is heap memory. So the actual object is created inside the heap memory, and that object address it is storing inside the C1 reference variable. And here, if you created another object, again in the heap memory, another object is going to be created, and that memory address is going to be stored inside this C2, right? When this program execution, see, this is your method, right? This is main method execution start, and this main method execution end here. And when the main method end, this location, this stack memory is going to be clear, right? So the memory allocation for C1 is 4 byte, memory allocation for C2 is going to be 4 byte, because this address is going to be an integer. Hello?
Yes, sir.
Okay, so how many minutes I have my screen faced?
It's around 15 seconds.
Okay, 15 seconds, not more than 15 seconds. Okay. So now you will get some better idea regarding this heap memory and stack memory with this image,
Yes.
which we discussed in our previous session, right? So actual memory allocation will be done inside the heap memory, and the reference variable memory allocation will be done inside the stack memory, right? Then this stack memory, this is a pointer pointing to the actual object, and C2 it's also like a pointer pointing to the actual object, right? When your main method execution completes, so this is your main method. Within this main method, we are allocating the memory for C1 object and C2 object, right? So when the main method completes its execution, this memory allocation will be deleted, right? But this memory allocation will not be deleted immediately. There is a concept called garbage collector who is take the responsibility to delete those objects. So when it is going to delete the object, at what scenario it is going to delete the object, we'll discuss those things in detail when we discuss the garbage collection concept, right? Right. So hello. Right. So now I hope you have understood what is exactly the stack memory, what when the memory is allocated inside the stack memory, and what type of things are going to be created inside the heap memory, and what happens when the method completes its execution to a stack memory, and when the object is going to be destroyed from the heap memory. I hope you understand, right? If you understand, let me proceed to the next concept. What is value types and reference type? As you understand the concept of stack and heap, now let us move forward and understand the concept of value type and reference type. We have already discussed. If a type is struct type, then it's going to be a value type. And if a type is class type, then it's going to be a reference type, right? Then what is the difference? Now the value types are the type that hold both the data and the memory location, memory in the same location. On the other hand, a reference type is a type that has a pointer that points to the actual memory location, right? Let us understand value type. So you can see here integer x and integer y are there, right? So here integer x is there, integer y is there. So x and y are nothing but your integer type. Integer type means they are value type. Value type means what is saying both data and memory location, right? But data and memory in the same location, right? So data and memory inside the stack memory only, right? So inside the stack memory, you are storing the data, you are allocating the memory, you are having the variable, everything in a single memory, right? So you can say value type, when you are working with the value type means you are working with only one memory. But when you are working with the reference type means you are working with stack and a heap memory. That is the point that you need to understand. Value type means, see, in this example, I'm only using the value type. Is there any concept of heap memory in the picture or in the diagram? No. Because value type means we are working only with the stack memory. And in .NET framework, right? So when we assign one variable value to another variable, then it creates a completely a copy in the stack memory. That's what you can see in the above image, right? So in this case, you can see integer x equals to 101. When this statement is executed, when the first statement is executed, it will allocate a memory inside the stack and it will store the value 101. And when you assign x to y, when you assign x to y, a completely new copy of the memory will be allocated for the y. So it is not going to store the same value inside the x, right? Y is now different memory allocation and x has a different memory allocation. And both these memory allocation are going to hold the value 101, right? And in .NET type, the the value data types are these. So we have already discussed in data type concept. Boolean, byte, character, decimal, double, in, float, long, s byte, in, short, u long, short, u in, struct, u short. All are example of value types. Is that clear?
Yes.
Okay. Now we need to understand reference type, right? So already we have discussed this example many times in our application. See, in this case, whenever I'm creating this one, some class obj equals to new some class. That means the new some class means this is your object creation statement, right? The object will be created inside the heap memory, and that object reference address will be stored inside this obj1. And when you assign obj1 to obj2, then what will happen? And that memory, so this reference address we are assigning to this obj2, right? So in this case, both this memory will point to the, both this reference variable will point to the same object. And I think if you have attended our call by value and call by reference class, then you should understand this concept very clearly. Because in call by value and call by reference, we have already discussed this concept. Okay, let me open that. See, in this case, when, okay, in this example, you can see this is the same thing. We are creating one object and then we are assigning this object to employee 2, right? Employee 1 object, that means you are using new keyword only one time, means inside the stack memory, only one object will be created. And that object reference is going to store in emp1 variable, right? So this is the pictorial representation. The object is created inside the heap memory. You can see employee ID, name, and this is the employee address. And that address we are storing inside this emp1 reference variable. And this emp1 reference variable having an address, because it is also a variable, but this variable holds the address of this employee1 employee object. This is the pictorial representation when these three statements are executed, right? And when you execute this statement, so what actually we are assigning? So we are assigning what emp1 is holding. emp1 address is this one, 11100, but emp1 holding the value 101011. That means that 101011 will be assigned to this emp2 variable. You can see emp2 variable is created with what with the value of emp1. emp1 value is this one, and that value we are assigning to this variable. And in this case, this variable, so this value means it is also pointing to the same memory location. Is that clear?
Yes.
Okay,
Yes.
this is already we have discussed in our previous articles, right? The same thing. So here, the object is created means object is created, and this object one is referencing to this object. And when I assign object 1 to object 2 means we are assigning the reference address to this object 2. And again, this one also pointing to the same object, right? Then the question is, how is the heap memory freed up, or how is the heap memory destroyed, or how is the heap memory is cleaned up? Okay, the memory allocation which is done on the stack is gone when the control moves out from the method. That is, once the method completes its execution, the stack memory will be clear, right? On the other hand, the memory allocation which is done on the heap needs to be deallocated by the component called garbage collector, right? When an object stored in the heap memory is no longer used, right? So garbage collector means when it is going to delete the object from the heap. Now, when that object is no longer used, right? If there is no reference to that object, then that object is going to be deleted, or you can say that object is eligible for garbage collection. And at some point of time, garbage collector will deallocate that object, right? So in this case, same. In this case, so you are creating this object, and you are creating this object means this reference address is there, right? If this reference is deleted, this CLS1 is deleted, is there any pointer who is now pointing to this object?
No.
No. That
Once
means
execution is over.
yeah, once the execution is over, this memory will be deleted. Once this memory is deleted, then there is no more pointer pointing to this heap memory object, this CLS1 object. That means when a no object is referenced to this object, right? When no reference variable is pointing to this memory or to this object, then that object is eligible for garbage collection, right? Then once it is eligible for garbage collection, then at some point of time, the garbage collector will come and it will destroy that object. The garbage collector will come and check whether is there any reference pointing to this object. Yes, then it will not delete the object. Again, it will check. Again, it will come and check. Now, is there any object reference pointing to this object? Yes. Again, it will not delete. After some time, after some point of time, again it will come and it will check. Is there any pointer or reference variable pointing to this object now? No, it is not pointing. Then it will mark that object as a unused object, right? Once it marked that object as an unused object, then after some time, we cannot predict when exactly, but it is the responsibility of the garbage collector to destroy the unused object. Once it marks the object as unused, then garbage collector will destroy that object automatically. We as a developer will not have to be worried about how the object is going to be deleted from the heap memory. It is completely the responsibility of garbage collector, right? But there is a concept called managed object and unmanaged object. Garbage collector will only delete the managed object, right? But if you want to delete the unmanaged object, then how you will do? That we will also discuss in our upcoming session, right? Because we have some concept called managed code and unmanaged code, right? Managed code is completely managed by the CLR. Unmanaged code is not going to be managed by the CLR, right? So if you have, if anyone working in industry, then they might have known the concept of a disposable interface, right? Dispose method. So that disposable interface or a dispose method are basically used to delete the unused object. We will see everything in detail, everything in practical, but not now, right? So for now, if you want, the heap memory object is not going to be destroyed by garbage collector. Sorry, this heap memory object is going to be destroyed by the garbage collector when and only when the object is no longer used. No longer used means what? Now, if the object doesn't have any reference, if the object doesn't have any reference, that means that object is not going to be used anymore. And when the object is not going to be used for anymore, then only the object is eligible for garbage collector. And once the object is eligible for garbage collection, then the garbage collector will come and will destroy that object. But that is internally managed by the garbage collector, right? So some people are saying we can explicitly destroy the object using gc.collect method. We'll see that practically, right? What is gc, how to use gc.collect method, right? So whenever we are making gc.collect method, it is not going to destroy the object immediately. gc.collect means we are just making a request to the garbage collector. Hey, garbage collector, can you please visit the memory stack? Can you please visit the heap memory and check if is there any unused object? If is there any unused object, can you please destroy them? So we are just making a request, right? Then it is up to the garbage collector whether he will destroy or not, right? We'll discuss those things in detail, but not now. But now you just remember the stack memory will delete it as soon as the method completes its execution, and heap memory is going to be deleted by the garbage collector, right? If anyone having any query related to the stack memory and heap memory related to the value type and reference type, they can ask me now.
No, sir.
Right? See,
This is clear. This is clear.
sorry?
This is
Clear? Okay. See, reference type, I'm saying object, string, class, right? Apart from, because we have seen object, data type, we have seen class, and we have seen string, right? Apart from this, we are also having something called interface. We are having something called delegates, right? These are also reference type. We will see what is interface, what is delegate. Everything is going to be covered as part of this course. But why I'm not saying anything related to interface and delegate, it will only make you confused. Why I'm saying class object string? Because we are only working with the class object string as of now. What we have already discussed, I'm only saying those things. But apart from this thing, we have interface, which is also going to be a reference type. we have delegate, which is also going to be a reference type, right? We will discuss those interface concept in detail. We'll discuss those delegate concept in detail because delegates are most very important, right? Framework uses the delegate concept frequently. We'll understand everything in detail, right? So